Welcome, dear friends. Today we are going to learn about sieve shaker, cyclone separator, air separator, back filter, illustration tank. Okay, so these are the equipments which are used to bring about size separation. Now, first, let's see what is a sieve shaker machine. The sieve shaker, it works basically on the principle, okay, of size separation based on the size of the particle. So we can say the powdered drug is separated according to its particle size using a number of sieves in a nest, which are then agitated for a rapid size separation. Let us see the construction. Standard sieves of different mesh numbers, they are fixed in a mechanical shaker apparatus with coarsest sieve at the top and the finest sieve in the bottom. First we will see the working, then we will see its diagram. The powder sample of 50 gram is placed on the top of the sieve, that is on the coarsest sieve. Okay, so this sieve nest, it is then fixed to a mechanical shaker apparatus and then it is shaken for a certain period of time, and the powder retained on each sieve is then weighed after the equipment has stopped shaking. Okay, so now this is a sieve shaker. This is the lid of the sieve shaker. These are the sieves of different sizes. Okay, now what we have to keep in mind, the coarsest sieve means the sieve number which have the least sieve number. Okay, that is kept here on the top, and the sieve which has the highest number of sieve number is kept below. Okay, so small sieve number represents coarseness, high coarseness, and large sieve number expresses fineness. Okay, so we are, suppose we have placed sieve number 10 here, then we will place sieve number 12, and then we will place sieve number 22, 44, 60, 80, 80, 80, 85, 100, 125. Okay, so in this way we have to arrange these sieves. Okay, so this is the receiving pan, this is the indicator bulb, and this is the regulator. Okay, you can fix the time for which period you want to shake that equipment. Okay, now what happens when you switch it on? Okay, first you will arrange this assembly, then you are going to pour 50 grams of the powder on this top sieve, and then you will place this lid. Okay, now you will fix this lid and then you will set the time period here and you will start the equipment. Okay, so now what will happen, this machine, it will start to agitate, or we can say it will start to shake. Okay, and after the time is over, it will stop, and then we will take out this lid, and one by one we will take out the sieves. Now after taking out the sieves, then we will weigh how much of the material is retained on each sieve, and that is weighed, and then we calculate the percent of the weight retained. Okay, and in this way we get the size distribution. The advantage of this particular equipment is that it is very inexpensive, simple, and rapid with reproducible results. The disadvantage is that if the powder is not dry, the apertures, they get clogged. It has a lowered particle size limit of 50 micrograms. Then during shaking, attrition also occurs, and attrition results into size reduction of the particles, and this result into errors in the estimation. The variants of sieve shaker are electromagnetic sieve shaker. Now next we are going to see cyclone separator. The principle is that in cyclone separator, the centrifugal force is used to separate the solids from the fluids. The separation, it depends not only on the particle size, but it also depends on the density of the particle. The higher is the density, the more its settling rate. Okay, so depending on the fluid velocity, the cyclone separator, it can be used to separate all types of particles, or to remove only coarse particles and allow fine particles to be carried through the equipment with the fluid. Okay, so basically the cyclone separator, it consists of a cylindrical vessel, and it has got a conical base at its lower part. The upper part of the vessel, it is fitted with a tangential inlet and a fluid outlet. Okay, fluid outlet is on the upper side. Now which fluid we are going to use? We are going to use a gas. Okay, so this extends inwardly into the separator, and at the base it is fitted with a solid outlet. Now this is the actual construction of the cyclone separator. Now this is the inlet. Inlet for what? Inlet for gas along with the powder particles. Okay, so it has got a tangential inlet. So after that inlet, this is the gas outlet tube. The gas comes out through this outlet, or the gas along with very fine particles, it comes out. Okay, then this is the outlet for clean air. Then this is for dirty air, and this is the cyclone body, and this is the conical section of the body, and this is the outlet. Okay, so when you feed in the cyclone separator with a very high velocity of gas which contains the um, powders, when it moves inside, then what happens? The fine powders, they can be carried with the fluid, but the coarse particles, they experience centrifugal force, and due to centrifugal force, it moves or it moves over a circular path, and then it comes out through the outlet. So in this way we have achieved the separation of fine and coarse particles. So we can say the working, it can be said to be as when you inlet or when you introduce the solid in the gas tangentially at a very high velocity, the particle, it gets the rotary movement within the vessel, and the fluid is removed from the central outlet which is provided at the top, and the rotary flow within the cyclone separator causes the particles to be acted on by the centrifugal force. Okay, so here, due to the action of the centrifugal force, the solids, they are thrown out to the walls, and thereafter it falls to the conical base, and then it is discharged out through the solid outlet. Now cyclone separators, they are mostly used for separation of suspension of a solid in a gas or air. It can be used with the liquid suspensions of solids for separation of the solids from liquids. It is also used for separating heavy or coarse fraction from fine dust. The variants of cyclone separator includes dark Dorclone and liquid cyclone. Now we will see air separator. It works on the same principle as that of cyclone separator, but in this case, the air movement is obtained by means of rotating disc and the blades. To improve the separation, the stationary blades, they are used. So by controlling these blades and the speed of rotation, it is possible to vary the size at which separation will occur. Now this is your air separator. This is the feed inlet. This is the rotating disc. This is the rotating blade. Sometimes this blade can be made to be stationary. Okay, so depending on the rotation of the blade, or if it is stationary, we can achieve separation of different sizes. Okay, this is the outlet for heavy particles. This is the outlet for fine particles. Now when you feed in this air separator with the particles, then what happened? Due to the rotation of the disc, high air currents are produced within this equipment, and the particles which are heavy, okay, they do not move along with that current of air, and hence they will immediately settle and they are taken out from this outlet. Whereas the fine particles, they can get moved along with the air current which is generated due to rotation of this disc and blade, and hence they move towards the wall of the container, and then they will slowly they will fall down, and they are collected from the outlet for fine particles. So this is the working of air separator. Now let us see, when the particles, they move inside, the blades, they are always rotating, they are going to produce current of air. Okay, and when the heavy particles, they come across this air, they are not its path of fall is not deflected by the air, and hence they fall through this outlet for heavy materials. Whereas these fine particles, they got carried away with the current of air, and hence they came out from this outlet for fine particles. So we can say the construction is very easy. It is conical. It has got a conical base, and in the upper part of the separator, the vessel is fitted with the feed inlet, and at the base there are two outlets. One is for fine particles, and the other is for heavy particles. The rotating disc and the rotating blades, they are attached to the central shaft to produce air movement. The working, as it is shown in the figure, the sample powder is passed through the feed inlet, which falls on the rotating disc. The rotating plates are attached to the same shaft. This produce a current of air, okay, as it was shown by the arrows. The fine particles, they are picked up and they are carried into the space where air velocity is sufficiently reduced. Then the fine particles, they drop and ultimately they are collected at an outlet which is meant for fine particles. The heavy particles, they fall downwards because of their high density, and they are removed from an outlet which is meant for heavy particles. The use of air separator is that it is many a times it is attached to a ball mill or hammer mill to separate and return oversized particles for further size reduction. So this was all about air separator. Now we will see what are bag filters. In a bag filter, the size separation of fines or dust from the milled powder is achieved in two steps. In the first step, the milled powder is passed through a bag which is made from a cloth by applying suction on the opposite side of the feed entry, and this facilitates the separation. In the next step, pressure is applied in order to shake the bags so that the powder adhering to the bag, it falls off, which is collected from the conical base. Okay, so the construction involves it consists of number of bags which are made up of cotton or wool fabric, and these are suspended in metal container. A hopper is arranged at the bottom of the filter to receive the feed. At the top of the metal container, a provision is made for vacuum fan and exhaust through discharge manifold. At the top of the vessel, a bale crank lever arrangement is made to change the action from filtering to shaking. So this is a bag filter. Okay, so these are the bags, and first we are going to apply vacuum, and then the powders which it is made to move through these bags, the fine powders, they move inside the bags. Okay, they get clogged, and the coarser ones, they are removed, and then the lever bell arrangement, it is altered, then it allows shaking. Okay, now why shaking is allowed? Because the vacuum is removed, and due to that removed vacuum, air moves inside, and the bags, they start to shake, and due to this shaking, the fine particles, they are removed from the bag, okay, which is entrapped into that cloth, and it is collected at the bottom. Okay, so working, we can say it is divided into two periods. One is filtering period and the second one is shaking period. So during this period, the vacuum fan, it produces a pressure which is lower than the atmospheric pressure within the vessel. Gas to be filtered, it enters through the hopper, it passes through the bags and out of the top of the apparatus. The particles are retained within the bags. Then comes the shaking period. So during this period, the bell crank lever, it first closes the discharge manifold, and air is going to enter through the top. So the vacuum is broken. So at the same time, it gives a violent jerking action to the bags so that they are freed from the dust, and the fines, they are collected from the base. The use of air bag filter is that it can be used along with other size of separation equipments like cyclone separator. They are used on the top of fluidized bed dryer for drying to separate the dust. They are used to clean the air of a room. Also, household vacuum cleaners. It is a simple version of bag filter. So this was all about bag filter. Now we will see eluteration method. So we can say eluteration is a process in which the size separation of the powders is based on the low density of these fine particles and high density of the coarse particles using fluid flow. The principle is that here in eluteration, it is a process in which the fluid moves in the direction which is opposite to the direction of sedimentation. Means what? We are going to make the fluid to move opposite to the force of gravity. Okay, so in this separation depends on velocity of the liquid or air and the size and density of the particle which is present in the mixture. So elutration is a process for separating lighter particles from a mixture of heavy and light particles using a vertical stream of gas or liquid. In sedimentation, fluid is stationary, but in elutration, fluid is in motion. So this is the basic difference. Okay. Now first we are going to see what is an elutration tank. Okay, elutriating tank, it is used to separate the coarse and the fine particles of powder after levigating. So what is done first, the dry powder or its paste, it's taken and then it is kept in the elutration tank, and then it is mixed with heavy or large quantity of water. The solids, they get uniformly distributed in the liquid by stirring, and then it is allowed to settle down. So depending on the density of the solid particles, it will either settle or it will remain suspended in the air. Now when the particle, it has got low density, it will remain floating. Okay, and when the particle, it has got high density, it will immediately suspend. Okay, because we are not going to add any suspending agent, it is just a mixture of powder and water. Okay, so the heavy particles, they will immediately come down, and the finer particles, they will be still dispersed in the water. Okay, so what we do in this case is we remove the sample at different heights from the outlets, and these are then dried, and the powder with various size fractions, they are collected. Okay, so this is the arrangement of elutration tank, we can say. So it is a simple tank, and at various level taps are adjusted. Okay, so what happens when we mix the mixture of powder and water, we allow it to settle for 5 minutes, and then what we are going to do, first we will open this tap for very fine particles. Okay, because the very finest particles, they will be still suspended in this area. Then in this area, fine particles will be present, then medium sized particles, and then the coarser particles, they will immediately settle. Okay, so we will get this type of separation here. So first we will open this tap, we will remove some portion from there, and in that we will get very fine particles, and these fine particles are then dried. Okay, so we get one fraction. From next, then we will open this tap, and we will get the particles of the fraction of fine particles. Then we will open this tap, we will get medium sized particles, and lastly we will open this tap to get the coarse particles. Okay, so in this way, all the fractions, all the sample which we have collected, they will be dried, and we will be so ultimately we have achieved the separation of the particles. Okay, so the next thing is, next elutration method is single separation with the mobile liquid. Now here, the apparatus which is used, it consists of a vertical column with an inlet near the bottom for the suspension. You can see from here the suspension is going to enter. An outlet at the base is provided for the coarse particles, and overflow near the top is provided for the fluid and the fine particles. So here, if the upward velocity of the fluid is less than the settling velocity of the particles, then it will result into sedimentation, and the heavy particles, they will settle down, and once they settle down, they can be removed from this outlet. Okay, so if upward velocity of the fluid is greater than the settling velocity of the particles, then elutration is going to take place. So thus the fluid velocity is very important inside separation by elutration. The one column will give you a single separation. You can observe here that separation is occurring only once. So we are getting two fractions. One is this of coarse particles, and this is of the fine particles. Okay, so in this way, when you get separation once, you get two fractions. Okay, the next is separation as multiple fraction. Okay, if your powder mixture contains more fractions of the powder particles, then we will go for multiple separation as multiple fractions. What we have to do, we are going to use the same chambers as we have taken for single separation, but you have to observe that the area of the first tank is very small as compared to area of the second, and the area of the third tank is the highest one. Okay, now what is going to happen when you move So if you want to separate more than one fraction, okay, then you have to take number of tubes of increasing area of cross section that can be connected in series. The velocity of the fluid decreases in succeeding tubes as the area of cross section increases, thus giving a number of fractions. And these fractions are separated and dried later on. Okay, so so this was all about illustration method. Now, what is the advantage of this method? This process is continuous. Depending on number of fractions required, the same number of tubes of different area of cross section can be connected. The separation is quick as compared to other methods of separation. The apparatus is more compact than as that used in sedimentation method. The main disadvantage of this method is that the suspension of the solid particle, it has to be very diluted. Okay, and then only we can get the separation, otherwise it is not possible. So this was all about the separating equipments which are used in pharmaceutical industry. Thank you for watching.